Mount St. Helens has seen an increase in earthquake activity with nearly 350 quakes over the last several months.
Now, scientists are saying this is part of the volcano's recharging process. KOIN 6 meteorologist Josh Kozar explains.
The ocean, a realm of mystery and untold wonders, hiding secrets beneath its waves for millennia. But what happens when those secrets begin to leak out? The United States Geological Survey, a name synonymous with exploring the Earth's hidden corners, has made a startling discovery. A leak, not in a pipe, not in a tank, but in the very floor of the ocean, and near one of the most volatile forces on the planet, Mount St. Helens. What is escaping from this mysterious breach? Could this be a sign of something far greater lurking beneath the surface? Join us as we delve into the depths of this unsettling discovery. Leak beneath the Pacific. The recent discovery of a leak on the ocean floor near Mount St. Helens has sent shockwaves through the scientific community. What began as routine geological mapping turned into a startling revelation when researchers detected anomalies using advanced thermal imaging. The leak, situated near one of the planet's most geologically active regions, is releasing superheated fluids laced with methane, carbon dioxide, trace metals, and rare isotopes. Unlike typical hydrothermal vents, this leak connects directly to magma reservoirs beneath Mount St. Helens, raising concerns about the stability of the volcano and the surrounding tectonic region. What makes this leak particularly alarming is its connection to Mount St. Helens' magma chambers. These chambers, already under extreme pressure, feed the Pacific Northwest's infamous volcano. Leaks like this act as natural pressure release valves, but their presence often signals instability within the system. Harmonic tremors, seismic events often associated with magma movement, have been detected near the leak site, further highlighting the danger. Such instability could trigger seismic activity or even a volcanic eruption. Scientists warn that the leak's location near the Cascadia subduction zone, an area prone to megathrust earthquakes, further compounds the risk of a catastrophic chain reaction affecting the region. The escaping fluid's composition causes equal concern. It is alarming that large amounts of methane and carbon dioxide are released as effluents. The former is over 80 times more effective than the latter in capturing heat in the atmosphere over a span of 20 years, thereby exacerbating global warming impacts. With rising ocean temperatures around the leak and localized warming, methane hydrate deposits have begun destabilizing in the vicinity, creating a dangerous feedback loop. Uncommon isotopes contained in these fluids are from deep inside the Earth's mantle, pointing to the fact that this leak taps into geologic layers very far under the crust of the Earth, which makes this already bad discovery worse. Such an unexpected finding has returned attention towards scientific interest in larger aspects of this leak. Is it part of a very large set of fissures concealed in the Pacific Northwest? Initial data have implied that the leak is indeed part of a system that is interconnected, with fissures running for several kilometers in extent. Most probably, mass migrations and die-offs of marine life are underway from near the leak point. The significance of a network such as this is huge in that it would likely accelerate the geological and environmental crises. The more advanced and complicated the technology that the researchers deploy to observe this rupture and the fissures around it, the more they seem to be discovering 100 questions for every answer. It highlights the seriousness of this issue under the fragile interconnected systems of this planet and the usual unpredictability of its hidden forces. This leak raised questions. Wait until you hear the answers. Leak's terrifying composition. The composition of the leak near Mount St. Helens is unlike anything scientists have encountered in the region. Initial thermal imaging scans revealed the release of superheated fluids, but further analysis uncovered a mix of methane, carbon dioxide, trace metals, and rare chemical compounds. These gases are typically associated with volcanic activity, suggesting a direct connection to the magma reservoirs deep beneath Mount St. Helens. The presence of rare isotopes in the leaked materials, believed to originate from Earth's mantle, indicates that this leak is tapping into geological layers far deeper than expected, raising alarms about the forces at play beneath the ocean floor. Methane, one of the primary components of the leak, is a greenhouse gas with a devastating impact on the environment. It is over 80 times more effective than carbon dioxide at trapping heat in the atmosphere over a 20-year period, making its release a significant contributor to global warming. The warming caused by volcanic or tectonic activity near the leak has already begun destabilizing methane hydrates in the region. These crystalline structures can release vast amounts of methane when exposed to even small changes in temperature or pressure. This feedback loop between warming oceans and methane release could have severe long-term implications for global climate patterns. Moreover, the leak is characterized by a very high concentration of carbon dioxide, another greenhouse gas with deep effects on the environment. Carbon dioxide substantially contributes to ocean acidification, causing marine ecosystem alterations and endangering the survival of different species. Initial studies on the water chemistry at the leak site reveal increasing levels of acidity likely to affect marine organisms already. Examples of unusual behavior of organisms nearby include mass migrations and die-offs, characteristics that explain how the leak may influence this delicate ecosystem's balance in the prospect of a threat to biodiversity and fisheries that coastal populations depend on for subsistence. The finding of rare isotopes in the leaked fluids adds another curious dimension to the puzzle. It's almost certain that such isotopes, rare near the Earth's surface, are indicative of deep mantle processes. Their presence not only constitutes further proof of the association of this leak to the magma chambers under Mount St. Helens, but also provides an insight into a larger interconnected geothermal system below this region. Initial observations indicate that this system is increasing both in size and intensity, generating interesting questions concerning the stability of the crust here. Will this be the forewarning of a bigger geological shift, or is it an isolated anomaly? The race has begun to answer that question. Danger beneath Mount St. Helens. Mount St. Helens, a name etched in geological history for its catastrophic 1980 eruption, remains a focal point for scientists due to its volatile behavior. The recent discovery of an ocean floor leak connected to the volcano has added a new layer of urgency to ongoing research. The leak, located near the Cascadia subduction zone, is releasing superheated fluids, methane, carbon dioxide, and trace metals, all of which point to extreme pressure within Mount St. Helens' magma chambers. Harmonic tremors detected near the site suggest magma movement, increasing the risk of an eruption. This leak acts as a natural pressure release valve, but its presence also signals instability in the volcanic system. If the pressure within the magma chambers continues to build, it could trigger a sequence of events leading to another eruption. The Cascadia subduction zone, where the Juan de Fuca plate plunges beneath the North American plate, is one of the most tectonically active regions in the world. This area is already known for its potential to produce megathrust earthquakes, which can reach magnitudes of 9.0 or higher. The proximity of the leak to this tectonic boundary raises concerns about a domino effect. A destabilized magma chamber could trigger seismic activity along the fault line, setting off a chain reaction of geological disasters. A megathrust earthquake in this region would generate massive tsunamis capable of inundating coastal cities like Seattle, Portland, and Vancouver, causing billions of dollars in damage and endangering countless lives. Perhaps the worst part of the danger is that the systems are quite interconnected within the volcanoes in this area. To geologists, the Cascade Range is a line of volcanoes linked by deep sources of magma. They have long feared the possibility of a chain reaction. An eruption from Mount St. Helens could awaken nearby volcanoes, like Mount Rainier or Mount Hood, generally leading to disarray. Historical data show that these volcanic systems have affected one another in the USA Cascades. This time, cities within the fallout zones will have major problems with ash clouds, pyroclastic flows, and lahars. The economic, infrastructural, and ecological futures hold disastrous consequences because of such a scenario. The destruction brought by this volcano is illustrated by the 1980 eruption of Mount St. Helens. 230 square miles of forest, 57 lives lost, and ash clouds circulating the globe. The stakes are much higher now because of a much larger population and more extensive infrastructure. The undersea leak underlines monitoring and readiness initiatives in ongoing campaigns. Emergency response teams are fishtailing, testing evacuation plans and infrastructure resilience, while scientists work non-stop doing research concerning the leak and its implications. With the predicted imminent eruption, this is a threatening perspective that will probably change the face of the Pacific Northwest forever. A ticking time bomb. The Cascadia subduction zone is one of the most geologically volatile regions on Earth, where the Juan de Fuca plate slides beneath the North American plate. This tectonic boundary is notorious for producing megathrust earthquakes capable of reaching magnitudes of 9.0 or higher. These massive quakes occur every 300 to 600 years, and with the last one recorded in 1700, experts warn that the region is overdue for another. The recent discovery of a leak near Mount St. Helens adds a new layer of concern, as it highlights the dynamic pressures building within this fault system. The interaction between volcanic activity and tectonic forces could accelerate the timeline for the next catastrophic event. The proximity of the leak to the Cascadia subduction zone has raised alarms among geologists. Fluids escaping from the ocean floor are linked to Mount St. Helens' magma chamber, suggesting a direct interaction between magma movement and tectonic stress. Harmonic tremors detected near the site indicate that magma is actively moving, increasing the likelihood of seismic activity. A megathrust earthquake triggered by this instability could generate massive tsunamis, inundating coastal cities and displacing millions of people. Such an event would devastate critical infrastructure, disrupt supply chains, and leave the region grappling with billions of dollars in economic losses. The geological complexity of the Cascadia subduction zone exacerbates the risks. The dynamic system, which harbors tectonic and volcanic activity, also contains great reserves of methane hydrates. Thus, destabilizing such hydrates may result in a cascading disaster. A megathrust earthquake may trigger methane releases that could in turn accelerate climate change and amplify the effects of the geological event. Their combined potential to trigger a reaction of earthquakes, volcanic eruptions, and greenhouse gas emissions speaks to Earth's interconnectedness and frail balance of forces in the region. The Cascadia subduction zone has long been regarded as a geological time bomb, and the discovery of the leak on the ocean floor underscores just how precarious the system is. International collaborations are now underway to work with scientists using advanced monitoring equipment to understand the activity in the zone. While it continues to be a great source of challenge to predict what will happen exactly when such disasters strike, it has never been more urgent to prepare for the worst-case scenarios, because the potential for this is there. In that context, the leak becomes both a warning and an opportunity to further the scientific understanding and the preparation against disaster, and to build resilience before the elemental forces of Earth. Hold on tight, because this next revelation takes things to a whole new level. Environmental fallout. The discovery of the leak near Mount St. Helens has revealed a troubling environmental threat with implications far beyond the Pacific Northwest. The escaping fluids, rich in methane, carbon dioxide, and trace metals, are potent greenhouse gases that significantly contribute to global warming. Methane, in particular, is over 80 times more effective than carbon dioxide at trapping heat in the atmosphere over 20 years. While the quantities currently released are relatively small compared to global emissions, the warming caused by the leak could destabilize nearby methane hydrate deposits. This domino effect would unleash vast amounts of methane, creating a feedback loop that accelerates climate change. Methane hydrates, crystalline structures that trap methane within ice, are common beneath the seafloor in tectonically active regions like the Cascadia subduction zone. Even slight changes in temperature or pressure can destabilize these deposits, releasing massive amounts of methane into the ocean and atmosphere. Localized warming from the superheated fluids escaping the leak site has already begun destabilizing these hydrates, raising concerns about a potential chain reaction. Such an event would exacerbate the frequency and severity of extreme weather events, rising sea levels, and disruptions to ecosystems worldwide. The marine environment has been bearing the early brunt of the leak, and thus far, studies have already verified important changes in the water chemistry. The major changes observed include increasing acidifications due to the discharge of carbon dioxide. Changes such as these have caused disruption in the delicate equilibrium that is essential to the support of marine life in these water bodies. Signs of biological mass migrations, mortality events, and abnormal behavior in marine species around the leak seem to indicate that the ecosystem is under stress. These changes further threaten the biodiversity and livelihoods of coastal communities, dependent on fisheries, and are more indicative of environmental fallout from the discovery. More than just a singular geological incident, The leak has opened up the idea that Earth's systems are connected in more ways than previously imagined, as scientists scramble to hastily assess the leak and related consequences. This crisis will also require the coordinated effort of environmental scientists to monitor and mitigate the fallout from the event, while investing time into researching a better understanding of the complicated interactions between geology, climate, and ecosystems. The discovery stands as both a warning of apocalyptic proportions and a rallying cry for humanity to address the problems facing this planet in rapid change. Possibilities of chain reaction? The discovery of the ocean floor leak near Mount St. Helens has raised fears about a potential geological chain reaction in the Pacific Northwest. This region, already one of the most tectonically active on Earth, houses interconnected volcanic systems that share magma sources deep beneath the Earth's crust. The leak's connection to Mount St. Helens magma chambers suggests a buildup of pressure that could extend to other volcanoes in the Cascade Range. Harmonic tremors detected near the leak site, a key indicator of magma movement, further heighten concerns that destabilization could set off a series of eruptions, each increasing the likelihood of the next, a scenario geologists have long feared. The Cascade Range, which includes prominent volcanoes such as Mount Rainier, Mount Hood, and Mount Adams, is closely linked through underlying magma systems. The potential for a volcanic domino effect has been theorized, where an eruption at one volcano triggers seismic activity and eruptions at others. Historical data shows that similar chain reactions have occurred in the region, making this scenario not just possible, but plausible. Cities like Portland, Seattle, and Vancouver, all within range of volcanic fallout, face risks including ash clouds, pyroclastic flows, and lahars. Beyond the immediate devastation, the long-term economic, infrastructural, and ecological consequences would be staggering. Increasing the risk is its proximity to the Cascadia subduction zone, which is already tectonically charged with enormous stress. Regionally, megathrust earthquakes of 9.0 or higher can strike, and destabilization from this leak could possibly even hasten that timeline for such an event. A geological catastrophe combined with a volcano eruption would cause megathrusts, which would cause tsunamis, landslides, and destruction across the Pacific Northwest. The environmental disaster, such as the release of greenhouse gases from magma systems and ocean floors, will worsen the global climate crisis. The potential for cascading geological disasters further reveals the interconnectedness of Earth's systems and the frailty of the geological landscape of the Pacific Northwest. Advanced technologies are presently used by scientists for monitoring this leak and the effect on seismic and volcanic activity. However, the timing of such events remains unknown. It very simply suggests that preparedness and resilience are needed urgently, with one event leading to another in a chain reaction that has ramifications across the globe. Historical evidence paints a chilling picture of the potential for a devastating chain reaction in the Pacific Northwest, extending far beyond the immediate earthquake zone. The Cascadia subduction zone, a volatile fault line stretching along the coast, has a history of unleashing immense seismic forces. The last major rupture occurred in 1700, a colossal earthquake estimated to have reached a magnitude of 9. This event not only caused widespread destruction along the North American coast, but also triggered a series of powerful tsunamis that radiated across the Pacific Ocean. These tsunamis, some reaching heights of several meters, traveled thousands of miles, leaving their destructive mark on distant shores. Historical records from Japan, dating back to January 1700, document the arrival of an orphan tsunami, a massive wave with no apparent local earthquake origin. This orphan has been definitively linked to the Cascadia earthquake, providing concrete evidence of the far-reaching consequences of such events. Beyond written records, the oral histories of indigenous peoples in the Pacific Northwest provide invaluable insights into the region's seismic past. Passed down through generations, these narratives recount tales of sudden land subsidence, villages disappearing beneath the waves, and canoes being tossed high onto the shore. These accounts, once dismissed as folklore, are now recognized as vital pieces of the puzzle, corroborating scientific findings and enriching our understanding of past earthquakes. Racing against time. The discovery of the ocean floor leak near Mount St. Helens has mobilized scientists worldwide to investigate the phenomenon and its potential ramifications. What started as routine underwater geological mapping quickly turned into a race against time to understand this unprecedented event. Using advanced thermal imaging, researchers identified superheated fluids escaping from the seabed. These fluids, rich in methane, carbon dioxide, and rare isotopes, indicated a direct connection to Mount St. Helens's magma chambers, sparking concerns about the stability of the region's geological systems. To study the leak in detail, scientists have deployed cutting-edge technology, including autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs. These tools are equipped with advanced sensors to map the seafloor, collect fluid samples, and monitor real-time changes in the leak's size and intensity. Preliminary findings suggest that the leak is not an isolated occurrence, but part of a larger network of fissures, creating what researchers are calling a submarine geothermal system. This interconnected system extends over several kilometers, highlighting the extent of geological instability beneath the Pacific Northwest. Some rare isotopes in the leaked materials have put further investigation into the case at a much complex level. This makes it judiciously difficult to make judgments about the leaked material, which even suggests tapping geological levels deeper. This is clearly against the huge arguments that volcanism and tectonics argue within these regions, and compels scientists to look into more vulnerabilities. Harmonic tremors, detected near the site, often associated with the movement of magma, indicate the possibility of an underwater volcanic eruption. Such an event has the potential to trigger tsunamis and disturb marine ecosystems. Several things remain unknown about the leak, even as research progresses almost at breakneck speed. Does the leak herald something much bigger in the geological scheme, such as an eruption at Mount St. Helens or a megathrust earthquake along the Cascadia subduction zone? Or could it simply mean wider geological instability within the region? While the researchers turn their minds and muscles to these questions, they also spend time developing predictive models to forecast possible impacts. Understanding this leak and mitigating risks, therefore, increasingly becomes urgent after heeding the ticking clock over the very fragile systems that comply with the Pacific Northwest. Science in motion. The discovery of the ocean floor leak near Mount St. Helens has left scientists racing to determine what this means for the region and the planet. One of the most pressing questions is whether this leak is an isolated phenomenon or part of a larger network of fissures beneath the Pacific Northwest. If similar leaks exist, they could indicate a broader pattern of geological instability with far-reaching implications. As researchers continue to study the leak, they are working to assess its potential impact on seismic activity, volcanic eruptions, and climate change. A key focus for scientists is monitoring the behavior of Mount St. Helens magma chambers and the surrounding tectonic system. The leak's connection to the volcano raises concerns about mounting pressure within the magma reservoirs. If this pressure continues to build, it could trigger seismic activity or even a volcanic eruption. Additionally, harmonic tremors and fluid migration patterns near the leak site are being closely monitored, as they may provide clues to imminent geological events. The leak's proximity to the Cascadia subduction zone heightens the risk of a megathrust earthquake, an event that could devastate the Pacific Northwest and create massive tsunamis affecting coastal communities. Advanced technology to mitigate the consequences of these risks has been applied for the purpose of tracking the leak during its effects in real time. Latest autonomous underwater vehicle, AUV, and remotely operated vehicles, ROV, retrieving data for the leak size, intensity, and composition. Coupled with these devices are seismic sensors for tremor measurements in the area. Researchers have further incorporated predictive modeling to simulate possible events, ranging from a localized volcanic eruption to a geological disaster affecting the area. The goal being to give these models very important information for emergency planning and disaster response, furthering international collaboration that has already been very essential in improving preparedness, and data sharing among the scientists has also opened up avenues toward further research and innovations. Still, though the research is ongoing, this doesn't allow one to figure out the true scope of the implications of this leak. Is it going to possibly end with a series of geological effects, or is it merely an aberration that will have localized influence? The time required to answer these questions is not yet availed. Until then, a ringing call towards vigilance and preparedness is indeed drilled up by scientists. This leak discovery is much more than just waking up the Pacific Northwest. It stands for Earth's unpredictably yet oft destructive powers, and calls out as well the importance of teamwork worldwide in such an occurrence within nature. Humanity's challenge. The discovery of the ocean floor leak near Mount St. Helens raises profound questions about humanity's preparedness, responsibility, and resilience in the face of Earth's natural forces. This phenomenon is a stark reminder of how interconnected our planet's systems are, with geological events influencing climate, ecosystems, and human societies. It challenges us to confront the limits of our knowledge and our ability to predict and mitigate the impacts of natural disasters. Are we ready to respond to the threats posed by this leak, or are we underestimating the magnitude of the risks? Scientific innovation plays a critical role in addressing these challenges, but it cannot work alone. The complexity of the leak and its potential consequences demand collaboration on a global scale. Governments, researchers, and communities must join forces to invest in cutting-edge technologies, improve infrastructure, and develop effective disaster response plans. The urgency of this collaboration is amplified by the growing pressures of climate change, population density in vulnerable areas, and the unpredictable nature of geological activity. These threats have shed some light on what appears to be an alarm on environmental stewardship and sustainability at a higher level than the immediate effects of the leak near Mount St. Helens. Leaking greenhouse gases from the ocean floor serve as strong reminders of the fragility of balance that sustains life on Earth. While we learn and develop lessons from understanding and mitigating the impacts of this discovery, we ought to also contend with how we pollute the environment. This includes protection of marine ecosystems, reduction of carbon emission, and investment in sustainable practices that lessen vulnerability to natural disasters. However, the most daunting challenge that humankind faces is not in the leaking oil pipe, but in how humankind is going to respond to it. This event gives a chance to reconsider the manner in which we relate to the planet and our position in its complex systems. Certainly, with the discovery of science, we can conduct global cooperation and develop resilience while turning this crisis into a moment of gain and understanding. It is not just a matter of survival, but defines how one can survive such challenges in an environment dominated by the strongest forces of nature. Get ready for the most crucial detail, a warning that you should not take for granted. A warning and an opportunity. The discovery of the ocean floor leak near Mount St. Helens is a stark reminder of the Earth's immense power and unpredictability. This phenomenon, which connects deep magma reservoirs to the surface, poses risks that extend far beyond the Pacific Northwest. From the potential for a catastrophic eruption or a megathrust earthquake to the acceleration of climate change through methane release, the implications are both alarming and far-reaching. This is not merely a geological curiosity. It is a warning that Earth's systems are interconnected, fragile, and capable of triggering dramatic changes with global consequences. Scientists are racing to understand the full scope of the leak, employing cutting-edge technology and international collaboration to monitor its impact. Advanced tools like autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, are providing critical insights, but the data gathered so far only scratches the surface of what may be a much larger issue. The leak is part of a broader network of fissures that highlights the scale of instability beneath the Pacific Northwest. Harmonic tremors, rare isotopes, and fluid migration patterns are helping scientists piece together the potential for a chain reaction of geological events. However, such discoveries challenge their depth into scientific investigation. Governments, lawmakers, and common citizens have to come together to prepare for potential disasters. Investments in infrastructure to withstand earthquake volcanic activity, evacuation plan development, and addressing greenhouse gas emissions and environmental consequences are a few among many. They would include possibilities but are not limited to joint monitorization of the leak and other tectonically active areas under threat of consequences. The tickings of the clock are getting faster, and everything we do hereafter will determine how much we can withstand the effects of this geological phenomenon. In the end, the discovery of the leak is ultimately both a warning and an opportunity. It brings out humanity's vulnerabilities while underscoring the possibilities for innovation, resilience, and cooperation. Research and disaster preparedness in climate action can complement each other and make this uncertain moment an opportunity for growth and discovery. The interconnected systems of our planet demand such a response, and this is a call to action for scientists, policymakers, and every individual to make their efforts known in taking responsibility for our common future, adapting to the changes lying ahead, and shaping a safer, more sustainable world through active contribution. Thanks for watching. If you found this video intriguing, don't forget to like, comment, and subscribe to stay updated on our latest content. Share your thoughts below. We'd love to hear from you. And before you go, click on the video right here to dive deeper into another fascinating topic. See you there.